Hi everyone, and welcome to today's Physics Daily Booster. This is number 12 in our Paper 2 series, and it is on the advanced information lists for both foundation physics and for higher tier physics. We are going to carry on with our 8.1 section on the specification, and what we did last time was we had a look at how to avoid crashing your car. What we're now going to do is understand what happens if you don't avoid crashing the car, basically. So if you don't stick to those actual stopping distances and drive far too close to the car in front of you, this is now what's going to kick in. So you are going to crash your car at this point. Let's see how we stop you dying. So let's kick off first of all with the idea of seat belts. Hopefully this is something that you automatically put on every time you get into a car, no matter what seat you sit in. It's been a legal requirement for many years now in the UK. Now, the whole purpose of a seatbelt is that when that car comes to a sudden stop, it is going to bring you to a stop, but more slowly than something that's rigid. Now, the reason that that works is that the seatbelt itself has some, and I mean some, kind of elasticity to it. So it's not a case of you can just go and like stretch the seatbelt with your hands like a rubber band, because that would be terrible. Obviously, if we think about the properties of rubber, you don't want that in a seatbelt because you don't want it to stretch and then fling you back. That would be terrible for injuries. Instead, we want it to just have a little bit of stretch so that it's going to bring you to a slower stop. The reason for that is that if you come to a stop more slowly, so the longer you take to come to the stop, the better in terms of the forces it exerts on your body. So that means you are less likely to suffer severe injuries. One point to note is that if you have been in a crash, then your seatbelts will need replacing because they will have been stretched as a result of that and therefore won't be as effective in a future crash if you make a habit of crashing that much, of course. If obviously you are one of these people who decides not to wear a seatbelt, then when that car comes to a sudden stop, you are going to continue moving at the speed the car was moving at until something stops you. Windscreen, dashboard, person in front of you, whatever it may be. So obviously that is not going to end as well. So because of that, obviously you're going to keep moving forward at potentially 70 miles an hour, 80 miles an hour if you're breaking speed limits, until something brings you to a stop. And usually if we're talking about things like a windscreen, it's a little bit more sudden than a seatbelt stop. So large forces and messy. Now, one of the things we do need to consider is why the speed at which you actually come to this slow and stop actually matters. And it's all to do with your accelerations. Because if that negative acceleration, so if that deceleration is very large, then what we find is seatbelts are in theory going to do a good job on stopping you dying, but not always. For the simple fact that if that negative acceleration is large enough, then you can suffer certain injuries here. So compression injuries from the seatbelt, or the more sort of gruesome one if you like, is where your internal organs basically just keep going and then smash into things like your ribs and get punctured by them as they shatter. So very unpleasant, but seatbelts still an awful lot safer than not wearing a seatbelt. Not perfect, not guaranteed to mean that you walk away absolutely injury free at all, not even guaranteed 100% to save you if the force is great enough, but sure as heck a lot safer than not wearing a seatbelt. And this is why. Here is our calculation. Force is mass times acceleration. Again, on the formula sheet, don't need to memorize it, just need to use it. If we think about the fact that obviously cars generally travel at 70 miles an hour if we stick to speed limits on motorways, and if you're in a crash, that 70 miles an hour is going to be reduced to zero quickly. Therefore, we're going to see a large change in the acceleration there. Now, if you imagine the mass of car plus people, and that's all multiplied together, that gives you a huge force. Even if you just did the force of the individual person times the acceleration, massive. So this is why we need to try to make that acceleration as small as possible. and therefore the longer the time it takes for you to have that change in speed, the better. So how do we do this? Well, obviously we've talked about seatbelts first of all, but we also have designs in the cars that are all about reducing those forces. And the way they reduce those forces is all to do with taking longer to bring that car to a stop. So basically making the acceleration smaller by using a greater time to change the velocity. One of these is airbags. So modern cars these days have airbags that pop out of pretty much everywhere. If you're in a crash, they will emerge from the steering wheel, the dashboard, the side of the car, seats, you name it. They're just literally erupting left, right and centre, all to do with protecting you, because they inflate very quickly, so that then as you hit them, you're then going to be brought to a slower stop as obviously they start to let that gas out. So it does help. And then crumple zones. This is one of the main reasons why our modern cars generally end up written off when they're in a crash, because they're actually designed to pretty much fold up. So different regions of the car have been made with different densities of metal, etc., so that in the event of a crash, basically that engine area is going to fold in a very controlled fashion. Whole purpose behind that is to avoid things like the sort of column from the steering wheel shooting into the actual passenger compartment itself and then spearing people. So instead we've designed the cars with these things called crumple zones, which, as I've said, when they actually come to a crash, then they fold up a certain way, keeping all the bits of the engine basically in the engine, because it's collapsed in a controlled fashion. And in doing so, it's taken longer to bring that car to a stop, and it's much safer for all. If there are bits you'd like to look at in more detail, then you can have a look at our P8 playlist on the channel. You can use your revision guides and of course have a look at some of the past exam papers to get a bit of a feel for the kind of questions. Then don't forget to join us again tomorrow for our next Daily Booster.